Hey everyone, so welcome back to my channel again, Intelligent Learners. In this video, we are going to discuss the proof of sum of the cubes of n natural numbers, right? So we have to find out the result of when we are adding the cubes of n natural numbers, like 1 cube plus 2 cube plus 3 cube dot 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 till n cube we have to find, right? So yeah, let's start with the video. Please see the complete video very carefully. Just nothing, only the calculation is important, so focus on the calculation. That's it. It's very simple. So basically we have to find out in this video the sum of the cubes of first n natural numbers, right? We have to do that. First thing that we are talking about is about the natural numbers. Natural numbers are those numbers which start from 1 till infinity, means they are positive numbers, right? We have to take n all positive from 1 till infinity. Because we are talking about n natural number, it means we are talking about from 1 to n. Okay, so let's have a writing now. So what we are talking about the n natural numbers. So 1, 2, 3, 4, 5, and up till n we are talking about, right? Then we are talking about their cubes. So 1 cube, 2 cube, 3 cube, 4 cube, 5 cube till n cube, and their sum, means we are talking about the addition of the n natural number up till n, right? Now, first question is why we are doing it. We are doing it because suppose we have to find out the sum of the cubes of first 7 terms, means 1 cube, 2 cube, 3 cube, 4 cube plus 5 cube plus 6 cube plus 7 cube. So if we don't have a formula, what we will do? We will do 1 cube is 1, 2 cube is 8, 3 cube is 27, 4 cube is 64, 5 cube is 125, and up till 7 we have to find out 249. Then what we will do, after opening the cubes, we have to add all the values. So it will take too much of time. But if we have the formula, then what we will do, if we have to find out the cube of first sum of the cubes of 7 terms, first 7 terms, what we will do, we will put n is equals to 7 in the formula and we can easily find out the answer. So what is the formula basically? So we are going to discuss about the proof of that formula, right? So now we have an identity. First tell me, what is the term before n? The term before n is 1 less than n, which is n minus 1 whole cube, right? So let's take these two terms, n and n minus 1, but we are going to take their subtraction and their powers we are taking. For the cubes, we are taking power as 4. If we have to find out like this, 4, 3 raised to the power 4 and so up to n raised to the power 4, we are going to take the identity of raised to the power 5. Okay, now why we are doing it? Let's have there is a thing about that. Now why we are doing it, let's have a discussion about that. Okay, we are doing it because this term and again also from there n raised to the power 4 will come and they got cancelling out. Okay, that's why we are taking n raised to the power 4. Okay, so let's have an opening first. So n raised to the power 4 is n raised to the power 4. Now we have to solve this one. So what we will do, we will just split 4 into 2 into 2 like this. Now we have a whole square formula inside the bracket. So let's open that. So it will be a square plus b square minus 2ab whole square, because there is a square again. Now let's have a whole square formula. Again, I have to apply it. So let's take this one as a and this one as b. So a square plus b square minus 2 into a into b, because this is the formula for the a minus b whole square. That's why I have taken minus here, right? Now let's open the bracket. A square, sorry, I forget to put the minus. So minus a square. So I'm changing the color right now to make it clear. A square, that is plus 1 plus 2ab plus 2n whole square, that is 4n square, minus. We can multiply 2n with n square and then 2n with n, and again 2 is there. So 2n into n square into 2, that is 4n square, and 2n into 1 into 2, that is 4n. So this will be the final result. So now we will open the bracket. All the sign will get changed because there is a minus sign outside the bracket. Cube. 2n into n square is n 4n cube, no? Into 2. And plus 4n. So they got plus. So they will cancel out. So what we are left with, basically, we are left with 4n cube Okay, according to the powers this will become minus minus plus because they are the like terms, this one and this one, they both are the same terms with power square. Then we have 4n and then we have minus 1. So the result of this is this one. Okay, so let's move to the next step. Now we don't need this calculation basically. So I'm writing this one on the top because I want this now. Okay. So n raised to the power 4 minus n minus 1 raised to the power 4, that is equals to 4n cube minus 6n square plus 4n minus 1. Now, because we are talking about the natural number, the natural number starts with 1 and we have find out this one. So we'll start with, for n is equals to, not 0, sorry. For n is equals to 1, 2, 3 and up till n again. Okay. Take natural number, capital N. So now we are putting n as 1, 2, 3, 4 up till n. So when n is equals to 1, put in this. So it will be 1 raised to the power 4 minus 1 minus 1, that is 0 raised to the power 4, that is equals to 4 into 1 cube minus 1 square plus 4 into 1 minus 1. Then n raised to the, when n is equals to 2, then 2 raised to the power 4 minus 1 raised to the power 4, that is equals to 2 into 2 cube minus 2 whole square plus 4 into 2 minus 1. When n is equals to 3, it will be 3, 4, 2, 4 is equals to 4 into 3 cube minus 6 into 3 square plus 4 into 3 minus 1, right? Then now let's have n is equals to n. When n is equals to n, the last term. So, okay, let's write the second last term. Before n, we have n minus 1. So when n is equals to n minus 1, it will be n minus 1 raised to the power 4. Then n minus, we are putting n as n minus 1. So minus minus is 2. So this will be this. 4 into minus 1. Last term when n is equals to n. So it will be n raised to the power 4, n minus 1 raised to the power 4, that is equals to 4n cube minus 6n square plus 4n minus 1. Okay, so these are the values. So when from n to n, now if we will add all the values, please see it very carefully. When we add all the values, so right will add with the right and left will add with the left. So these are the left values, these all values, they are the left values. So when we add them, so this will cancel out with this because 1 raised to the power 4 is of plus and 1 raised to the power 4 is of minus. This will this, then this will also cancel, means every term will cancel out except this one and this one, because this is also cancelling out, this is also cancelling out with this. So what is left out when we add all the terms? We are left with this in the left, and see, these values will get added. So I'm taking 4 as common. So what is left? 2 cube, 3 cube till n cube. Okay. Then these values will get added with each other because they are the like terms. So because there is a minus sign outside 6, every 6. So take minus 6 into 1 square plus 2 square plus 3 square dot 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 n square. These all values are the like terms. So plus 4 into 1 plus 2 plus 3 dot 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 plus n. And there are so many ones. And how many terms we have? We are talking about n terms. So it will become minus n, right? So this is the final result. Now after this, please have a very important thing. We have done in the previous video, previous videos, we are talking about we have talked about the sum of the squares of n natural number, and we have talked about the sum of the n natural numbers. Like in the previous video, we know that, see, first of all, see this. This one, 0 raised to the power 4 is nothing. We are left with this here. 4 into, we have to find out the value of this. So we are doing the proof of this only. Okay, so we are not touching it. We will like this only. Minus 6 into. See, we have done the sum of the square of n natural numbers. We have the formula. Please see the previous video for that. So I will put the link in the description box of that. So n into n plus 1, 2n plus 1 by 6. Okay, this is the final result of this one, plus 4 sum of the square of n natural numbers. That is how much? N by 2, 2a plus, and the first term is 1 only, na? So don't take, so it will be, okay, n multiply n plus 1 divided by 2. Let's take it as simple as that. And minus n. This is the final. Now what we are going to see, let's have, so n raised to the power 4 is equals to, we are taking, because we have to find out, okay, don't take anything else, take this one, right? Exactly as same as that. 6 cancel out with 6. Let's open this one. So it will be n square plus n and 2n plus 1. Okay, 2 with 2. Now next left with plus, to 2 multiply with n, 2n, n plus 1 and minus n. Okay, now after this, what we have to do, n raised to the power 4, that is equals to 4 into 1 cube, 2 cube, 3 cube, plus still n cube. Let's open these two brackets. So multiply this bracket with this. So 2n into n square is 2n cube. Then 2n with n, that is 2n square. Then 1 with n square, and 1 with n is n. Plus, let's open this 2. So it will be 2n square plus 2n minus n. Okay. Now 4 into, again I'm writing the same terms, and cube. Now let's open all the values. So this will become 3n square, and when we open the bracket, the sign will get changed. So I'm opening the bracket, and if there is a negative sign, the sign will get changed. Plus, they both solved. So 2n minus n is plus n, right? Now, anything that is cancelling out, no. Now, what we will do, we will just left this one alone. So what we will do, we will take all the terms in the right side to the left side with n raised to the power 4, right? So after this, what we are going to do, n raised to the power 4 minus, see, when we will take all the values to the left hand side, sign will get changed. So 2n square, 3n square plus 2n square is minus n square, and we'll change its side. It will become plus n square, and n cancelling out, right? So nothing is left with here. So n, 1 cube, 2 cube, plus 3 cube, plus dot, 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 n cube. Now we take n square common here. So n square I have taken common. So it will become n square 2n plus 1. That is equals to 4, 1 cube, 2 cube, 3 cube, dot, 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 plus n cube. So this is a quadratic equation. We can easily solve the quadratic equation by doing middle term splitting. Like this, I have taken n, 2n as n plus n. Right? So n square, so it will become, so take common from these. I have taken this. You know how to solve the quadratic equation, okay, by using middle term splitting, or you can choose any other method to sort out. Now, what we are left with, n square, n plus 1, again n plus 1, is equals to 4, 1 cube, 2 cube, 3 cube, plus dot, 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 n cube. We have to find out the proof of this. So we left this one alone in the right side and take 4 to the left hand side. So it is in the multiplication here, and it will go in the division. So n plus n is what? N plus 1 whole square divided by 4. So this is the final proof of the sum of the cubes of n natural numbers, right? So this is the proof. What is the proof? N square multiply n plus 1 whole square divided by 4. Now, if you have to find out the sum of the cubes of 7 term, you can put n as 7. If you find out the sum of the cubes of first 6 term, you have to take n as 6. So like that you have to do, right? So this is the simplest formula. So very important thing, that which identity you are going to use, because you are using the identity n raised to the power 4 minus n minus 1 raised to the power 4. You are using that identity. Why we are taking power 4? That is important, because we are finding the sum of the cube means power 3. So for power 3, you have to take the identity of n raised to the power 4 minus n minus 1 raised to the power 4. If you have to find out the sum of the power 4 of first n natural number, you have to take power as 5. So one power greater you have to take to find out the sum of the powers of a natural number, right? So thank you everyone. Thank you so much.